Okay, wonderful. So now the question is, how well does this theoretical model that Goldman and Katz lay out describe the real world? Right? In other words, can we use this model to accurately describe and explain the changes in the college earnings ratio that we see over time? The way they're going to do this is by turning this theoretical model into a regression model. And the reason that's going to be helpful is because, as we've talked about, what a regression does is it lets us try to guess our dependent variable on the basis of our independent variables. So if they would lay out a regression that helps them accurately guess the college earnings ratio at each period of time as a function just of this steady change in technology and of the ratio of skilled to unskilled workers, then they can say that this might accurately describe the dynamics of the economy. Okay, so how do we turn this into a regression model? Well, what they're going to do, they're basically going to take the log of both sides. They'll say log WS over WU equals the log of lambda t over 1 minus lambda t times st over ut to the rho minus 1. Now, because of the way logs are constructed, we can break this apart. So we can say log lambda t over 1 minus lambda t plus rho minus 1 log st over ut. Right? We can bring exponents down and multiply another log rule. Well, now we have something that looks a lot like a regression. Right? We have two independent variables. We have technology. We have education. Then we have a coefficient in front of education. So they're going to take this and they're going to turn it into a regression where they say log WS over WU is going to equal beta 1 times technology plus beta 2 times log st over ut. Right? Where beta 2 then is going to be our best guess about the relationship, right? The average relationship between the skill ratio and the wage ratio is going to be able to be an empirical estimate of this rho parameter. Right? It's going to tell us essentially the degree to which skilled and unskilled workers are substitutes or complements. We'll leave that to the data to decide. Now, the only problem here, this is a real thing we can measure, right? We can count skilled workers and count unskilled workers. This is a real thing we can measure, right? Beta 1, beta 2, as we said, are abstractions. This technology thing here is not a real thing we can measure. So what they do is they say, well, our claim is that essentially technology just chugs along year after year after year with similar changes in skill bias technical change in every year of the 20th century. So they're going to describe technology just by putting in a value year. Right? 1950, 1951, 1952, etc. And the reason is, the argument is, each year, right, increases technology by the same amount, so a 1 unit increase in year should increase technology by the same amount. And this way, beta 1 is going to end up estimating for us essentially the amount that technology changes in favor of skilled workers in every year of the data, on average. Wonderful. So in table 2 in the paper, we can see what they actually find when they do a slightly complicated version of this regression. So this first column here is essentially the estimate of what we call beta 2, right? The relationship between the relative availability of college grads versus high school grads and their relative wages. What we can see is that the estimated coefficient, their estimate of beta 2, is going to be about negative 0.55, right? It depends a little bit on the version of this model that they run. What that tells us is that they're estimating rho minus 1 as being about negative 0.55. They're estimating rho at being about 0.45. So that tells us that according to their model, skilled and unskilled workers are substitutes, but they're not quite perfect substitutes, right? If they were perfect substitutes, rho would be 1. If it was closer to Cobb-Douglas, rho would be closer to 0. If they were complements, rho would be negative. Now, how about this coefficient on year, right? This change in technology year after year after year. So they're going to estimate that in this column right here, right? Time. And essentially what they're going to find, let's just look at this first column here. they're going to find a coefficient of 0.00378. That's very, very small. But they do a couple things to mess with the model that we lay out. The first thing they're going to do to mess with this is, sorry, I highlighted the wrong thing, right, just this here. They're going to add these time times post dummies, right? Time times post 1949, time times post 1992. The reason they're going to do that is they find that in their data, they don't actually find evidence consistent with the same change in technology year after year after year. Their evidence is more consistent with technology growing faster at some periods and slower at other periods. So what time times post 1949 is going to do is essentially they're adding to this regression, right? Year times year greater than 1949. So in years before 1949, this is equal to 0 because this thing is 0. In years after, every year adds 1 to this variable. So if we want to think about how much technology changes in 1950, 1951, et cetera, it's going to be this really low number, right, 0.00378, plus this larger number, 0.018, right? So they're essentially going to say that skill bias technical change really picked up, really only started taking off in a serious way after 1949. On the other hand, they're going to find that after 1992, skill bias technical change seems to have slowed down a little bit relative to the mid-20th century. So in some sense, this supports the argument that in the early 20th century, there really wasn't a lot of technological change that benefited skilled workers. On the other hand, it's also a little surprising because they're finding that in this period after computers become important, the advantages to skilled workers actually slow down relative to the middle of the 20th century. Okay, wonderful. Last thing I want to show you, we'll talk about all these results in more detail once we're all together. The last thing I want to show you is essentially this graph they do, where they compare the predicted values of the college earnings premium from their model to the actual values, right? So we're essentially saying, how good is their guess, their regression-based guess, holding up against reality? And essentially what they're going to find is that their guess holds up very, very well against reality. Not only does it capture these sorts of broad trends over time, it also captures most of the small details, with the one exception of this period, in 1949, where they expect the wage premium to drop pretty considerably, and it really doesn't. But for the most part, they're going to do a very good job of describing the actual changes in the economy with this very minimal model. Okay, wonderful. So I'm going to leave it there. I'm very much looking forward to talking to you about this in detail once we're all together. The last thing I want you to think about before we talk about this in person is to think about whether you really believe this story. In particular, whether some of these other arguments we put forward about unionization or more detailed changes in technology might also be going on behind the scenes. Okay, thank you so much. Looking forward to talking to you soon. Thank you so much for bearing with me.